Hey everyone, and welcome back to the Foundry by Forge College. Now, in our last explainer, we waded through the totally fascinating, but admittedly kind of dense waters of the principles of data sharding. Today, as we continue our track on Ethereum dev stacks and frameworks, we're shifting gears. We're moving from distributing data to mastering the master blueprints of automated smart contract deployment. This explainer is basically your survival guide to deploying smart contracts with confidence, helping you build a foolproof automated assembly line for your code. So let's just jump right in.
Okay, I need you to be honest with me for a second. Have you ever accidentally paid gas to deploy the exact same contract twice? Yeah, it's a highly relatable and painfully expensive beginner mistake. I mean, we've all felt that little sting in our crypto wallets, right? When you rely on manual deployments, your workspace is basically just a messy, chaotic workshop where things get dropped, forgotten, or worse, duplicated. And that right there is exactly why we desperately need a structured blueprint to automate this process safely. Ultimately, we want the code to do the worrying for us.
Here is today's agenda. We'll be looking at 1. The deployment lifecycle. 2. The magic of idempotence. 3. Hardhat tools and integrations. And 4. Structuring multiple environments. All right, Section 1. The deployment lifecycle. Think of your deployment script as a 4-stage automated assembly line. You've got prepare, execute, verify, and record. Think about it like a real physical factory. You wouldn't just start building a car blindly without first checking that you actually have all the parts, right? And you definitely wouldn't ship it out to a dealer without stamping the VIN number on it at the end. Well, your smart contracts require that exact same level of discipline.
Let's look a little closer at these stages. Prepare is where you check for your compiled artifacts and validate your configuration. Execute is running those deterministic deployment steps. Verify is where we wait for those mined transactions and perform our on-chain checks. And finally, record saves the address and transaction hash straight to a registry. The absolute key takeaway here is that those fail-early checks in the prepare stage prevent mysterious, super expensive runtime errors from breaking your assembly line later on. You literally want to catch the error before you spend the gas.
Moving on to Section 2, the magic of idempotence.
So, idempotence. It's a big, fancy word, but what does that actually mean? Basically, it's a deterministic guard that prevents accidental redeployments. It simplifies your automation by just checking if a specific task is already complete. Put simply, it is the intelligent fail-safe that stops you from burning gas on a contract that is already living happily on the network.
Seriously, imagine the absolute chaos of running ad hoc scripts with no registry file. You run it, it deploys. You accidentally run it again, it deploys again and just drains your funds. No thank you. Now compare that mess to the elegance of a per-network registry file. Your script simply observes the file, sees the addresses already in there, and peacefully skips the redeployment. No wasted gas, no duplicated contracts. Honestly, it's a beautiful thing.
All right, Section 3, Hardhat tools and integrations. You can treat this like a materials ledger on a patent document. First up, we have HAR. That's the Hardhat Runtime Environment. This provides your network metadata, your configured paths, and plugin integrations. Next is ethers.getContractFactory, which actually creates the deployable contract factories directly from your compiled artifacts. And finally, the script file itself, which orchestrates that whole prepare, execute, verify, record lifecycle we just talked about. Basically, Hardhat seamlessly ties your network metadata and compiled artifacts together.
Next up, Section 4, structuring multiple environments. You know, it is such a common beginner trap to rely on messy ad hoc scripts. You end up scattering if-else statements everywhere, creating this tangled, brittle web of logic. It's a total nightmare to debug. The professional strategy is to use a clean, environment-aware structure. This means you completely separate your deploy logic from your environment configurations.
Let's see how this actually builds a solid foundation using a standard directory layout. Your scripts folder? That holds the entry points. Scripts/lib stores your reusable helper functions. Over in deployments/config, you've got your per-network configuration files. And finally, deployments holds the generated registry files. By keeping your deployment decisions in these small, easily reviewable config files, you drastically reduce human error when switching targets, like say moving from a local testnet straight to mainnet.
And guys, the concrete advantages of this architecture are absolutely huge. First, predictability. The exact same script logic runs everywhere, only the configuration itself changes. Second, testability. You can easily mock configurations in unit tests without ever needing to hit a network. And third, separation of concerns. Your helper modules encapsulate all that complex logic.
This makes code review and risk assessment so much easier for your entire engineering team. Basically, everyone gets to sleep a little sounder at night.
All right, Section 5, Summary and Next Steps.
To wrap this all up, here are your 3 golden rules of automation. Number 1, implement simple registries for idempotence. Number 2, ensure environment awareness with config files. And number 3, fail early with explicit artifact and network checks. If you follow these 3 rules, I promise your smart contract deployments will be repeatable, reliable, and fully auditable.
So what's next? Well, get ready for our next lesson, Hardhat deployment scripts in practice. Next time, we are actually going to roll up our sleeves, put all these patterns into practice by writing real Hardhat scripts and integrate them with continuous integration flows. It's going to be a great one. You definitely won't want to miss it.
Before we go, I want to leave you with this final provocative thought. Automation isn't just about speed, it's about encoding your assumptions into repeatable, fail-safe operations. And that right there is the true value of a deployment script. It literally protects you from yourself. I really hope this explainer gave you a solid conceptual model to work from. Now, to dive even deeper and explore more amazing Web3 learning resources, be sure to visit forge.college. Thanks so much for watching, and I'll see you in the next explainer.